Now that you're done preparing your presentations about how individual actions can help contribute to the success of smart grids, and also what incentives are needed to achieve this, I'm going to start with the group presentations.
Okay, so we're going to present about smart grid barriers. My name is Justin.
My name is Mert. I'm Matthew.
I'm John.
Okay, so let me see this. Okay,
So basically a smart grid can basically compile a lot of sensors and a lot of inputs from lots of different houses. As you can see, all of these are all interconnected. So it'll actually streamline communication between people and technology. So let's say you have an oven that you want to turn off after a certain amount of time. Well, once the timer goes off, it can actually turn it off by itself, instead of you having to move everything and press buttons and things like that. So there are different aspects of smart grids that make it one of the better ideas right now. Energy generation and storage options are one of the bigger deals because a smart grid can use any type of energy, and it can also work with energy generation techniques. So gasoline, air, I think fossil fuels or hydro, and is that nuclear?
Yeah.
Okay. And so it's very open in the ways it can interact with other communities. So if your city doesn't have, say, a dam to get water sources from, but it's very open to solar power, well, it can accommodate to that. Or if you're more open to hydropower, it can accommodate to that. So it's a very nice open system. It also, thank you. So the power quality and energy efficiency are also big points, because the power quality will be much cleaner than using just fossil fuels, which which can cause harmful CO2 emissions. The energy efficiency can turn off certain points that you're not using, so you're not very wasteful of the energy you're using. So you can actually save a lot more money than you spend on the first basis here.
right. So while we have a smart grid all planned and it sounds very ideal, it can't be done without like the help of consumers and the general public. So here's a list of what consumers can do to help.
So our goal is to have a greener world and at the same time have a more efficient and a more productive daily life. And with the electric cars, our smart grid products and appliances, we can actually do this and we can actually improve this. And another example will be Moore's law, which is production and affordability of technology will increase exponentially with consumer support.
So technology gets cheaper over time, especially if it gets more mainstream. Then more companies will look into going into competition, which actually makes the products better. Because if companies have to fight against each other, then the person who wins out is the consumer, because you have more choices, which is always good.
And another way consumers can help is promoting the use of sustainable energy, whether through personal use or when there is government or business projects to support those too. And then sustainable energy is many different sources. You can have solar energy, hydro energy, geothermal, wind, and even through waves. Right, and passing on a message is a simple way of promoting ideas. And simply telling your friend, telling your family, through advertising, and definitely the media, everyone pays attention to. And it's shown in this graph.
Basically, there was a Consumer Collaborative 2012 survey, which asked people, what did you know about a smart grid? Well, it's very surprising because almost 50% in each wave of questions, 50% of people have not even heard of that term. 20% of people heard of it, but they didn't really know what it was. And only about 20 to 30% knew what people were meaning. So this obviously means that a whole consumer base is not being touched upon. That we haven't even begun to affect all of society. And we can start by talking to people about this and letting the message out that there are easier ways.
Basically, educate them.
Yes, educate people.
All right, so then it's not easy for consumers to change, so we need incentives to help promote change. So simply informing them that everyone's aware of these environmental issues, which are very pressing. But if we promote that smart grids are green and then they can help counter these environmental issues, that's one way of convincing people, because then they can help the world if they help smart grids.
Smart grids also help to saving energy and saving money.
Yep. And everyone wants to save money, so if you choose smart grids, why would you say no to saving money, right? Okay.
I can go. It also provides energy flexibility and storage of energy. Counter blackouts does not waste energy. Also, government organization incentive programs, energy plan, rebates.
So what BC Hydro has done in Vancouver is that if you buy certain Energy Star product appliances, they'll give you money for buying those because it saves the environment. So if we can get more governments to help out with these incentives, we can get a lot more people on board.
So we hope you all learned something about how smart grids can help the environment, how they're efficient, and hopefully you can help promote smart grids too. Thank you.
Thanks for listening.
So we're here to inform you guys further if we can do that about smart grids and their benefits. Marwan, Jeremy. All right. How can individuals help promote smart grids? How can they help roll the system out? Well, actions you can do is spread out energy consumption. Yeah, as an individual, you have needs. You have certain things to do. You wash your clothes. You wash your dishes. With smart devices, you're able to wash your dishes. Let's say 2 a.m. Wash your clothes at 3 a.m. You wake up in the morning. You still have the same results. Everything is done, but it's at a different time. You're using the energy at a time where, let's say, it takes a bit of load off the morning and the afternoon times. So that as a whole helps out with the community's energy consumption, right? It puts lower load on think of it as a rush hour times, and then it puts a little bit higher load at night when there's not as big a load, right? Conserve energy. That's going to lower the demand. So let's say you have a car. If you can, once a week, bike to where you want to go. That's going to conserve energy. Conserving energy as a community, you, your friends, your family. When everyone does this, people are going to have to keep companies aren't going to have to keep a high demand. Without having to keep a high demand, prices are going to drop, and with prices dropping, it's like, I mean, you're happy there's low prices, and as a whole, you're lowering carbon emissions, and it's just better for the environment, right? Buy energy efficient appliances. That ties into the first point somewhat. By energy efficient, we mean that they are smart. They can work at different times, but also the way they use the energy. I mean, you can have a stove, an electrical stove, that wastes, let's say, 60% of the electricity to make heat of what it gets, or you can buy a stove that's made high quality, that's using a higher percentage of the energy that you get for the same job you're doing. Last one is, I think, one of the major issues is support attempts to modernize. If there's a bill in your city or a bill in the town hall that's trying to get people to accept the smart grid, the whole smart grid ideology and smart devices, be a part of that. Tell your friends, tell your family, support it, because a lot of people, their mentality, as the previous group mentioned, if it's not broken, don't fix it. That's one of the reasons that people don't want to modernize. They see, hey, it's working. Why do I want to spend money to fix something that's already doing the job I want, right? So you got to change that mentality. Enough people can do that. That can help us out as a whole.
Incentives, cheaper prices at night. People have to be informed about what times the prices go down and when you can use your washing machine, your fridge. But with the smart grids, they don't have to wake up at 2 a.m. or 3 a.m. when the prices are the cheapest. you can use the smart grid that will turn on your washing machine, turn on your fridge, turn on all the appliances you might have at home, and use it when they are more efficient and more cheaper.
We have to inform the advantages of smart grids, the public to promote the use of smart grids. If without the smart grids, the public have to provide electricity, even though people use different amounts of energy. But by using smart grids, the public can optimize the energy consumption and less downtime.
Okay, so there are various possible future changes which can be made thanks to smart grids. For example, you could have giant batteries in your house, and while the prices are cheaper, the smart grid would charge the batteries, which would load them with energy, which you could use while the prices were higher. So essentially, you're paying less for energy on what would normally be an expensive time. And there are various possible ideas which people could come up with in the future thanks to
Hi, my name's Amin from Aditya, and we're going to tell you stuff about smart grids. These are the topics about how individual actions contribute to promote energy efficiency. Well, there's obviously not using fossil fuels, using other stuff like solar-powered appliances, wind-powered, and electric-powered, and use it with the smart grid, obviously, to as energy distribution.
Buying wind power operated products will induce mass producing wind turbines for commercial use, thus allowing for clean energy. Also, buying wind powered operated products will allow reducing CO2 emissions.
Solar panels use the sun rays and converts it to clean energy. A lot of the energy the sun emits gets rebounded in the atmosphere, and then the rest is absorbed by the earth. The remaining energy is still a sufficient amount to power our everyday lives. So if consumers were to use solar-powered energy, like a lot of energy from the sun would not be wasted, and it would actually be of use on Earth, and it would greatly affect us by not using fossil fuels, which is in demand today because of the lack of fossil fuels. Well, as you can see here, electrical power appliances. There's new designs about cars having to use electrical, are powered by electrically, and it obviously stops carbon emissions because, well, normal cars use petrol and gasoline, which produces carbon dioxide, which affects the temperature of the earth and causes air pollution. Electrical based appliances, they don't use carbon-based stuff, so it won't really damage the planet that much, and it'll be more efficient because you're using electrical power. Here, this is smart grids. They help distribute of energy more efficiently because you can send energy throughout your places that has high demand over it. The incentive would be like other groups said, at night it can operate where it's much cheaper to use energy, and it'll be much beneficial to the consumers because you're not using it in your own time, which is say when you're asleep, it's getting it done for you, whereas in the afternoon, in the morning, it takes up time for you to actually do the work.
So basically the incentives for consumers, if you got to include it in the slide, would be because they save money.
Is
good for the is better for
Cleaner.
cleaner energy and good overall.
Okay, so we're going to present you smart grids. Individual actions that can be taken are quite obvious. To use renewable energy, which is infinite, that means you can use it over and over again, not like fossil fuels that actually are finite. You can use renewable energy as hydroelectric power, solar power, geothermal power, and all of these types of power will reduce carbon emissions.
And using less voltage to reduce the consumption of energy is the secondary suggestion. And as you see this picture, the right one uses a higher voltage than left one. So we recommend to use this left one because it reduces the consumption of energy.
And what's amazing about it is that actually the ones that use less voltage are a lot more brighter.
And thirdly, stop using things you want but you don't need. For example, open the door instead of using air conditioner, and it is our third suggestion.
Then what is needed to achieve this? We need the user to be informed about how to make a smart grid, how to use the how the smart grid is going to help. Current situation about energy use, carbon emissions, and the smart grid usage.
And so that's the presentation.
Okay, thank you so much.
Alright, so today we're going to teach you about smart grid barriers. So, as a consumer, there is some obstacles and concerns about smart boards or smart grids. So some concerns may be the consumer's privacy. It invades their privacy because the electronic devices that the consumer uses is being tracked by the smart grid operator. There is a computer security problem also, because there could be a potential of hacking of this smart grid system. There's a possible cost of installation and maintenance fee.
Okay, so we've already seen the possible, what can I do? So promoting smart grids to friends, family, neighbors is a very important solution. We don't have the statistics that the other group did, but as we've seen, 50%, I think, didn't know anything about smart grids. And the second option would be to use renewable energy to share your knowledge and to share your energy. For example, if you have extra solar power, if you have solar panels on your roofs and you don't use all of the energy, why not share it with your neighbors? And on the graph you can see, it just demonstrates that all houses, factories, everything is interconnected. So it's a very important factor that everyone has to agree upon.
Okay, so these are possible incentives. So what can our government do? Well, obviously they could put government regulations that people must use smart grids, but then that wouldn't be very popular with the people. So they can use incentives. First of all, they can provide these smart meters for free or at a reduced cost. And they could introduce government tax returns on the purchase of these smart meters or more energy efficient electronic devices. And lastly, which is similar to the second one, the government could choose to subsidize the upgrading of old, less energy efficient equipment to more modern and more energy efficient electronic devices, such as fridges or washing machines.
All right, thank you for your presentation.
Thank you so much for all the presenters. In a short amount of time, you managed to come up with so many ideas for the next few years, and some were even ahead of time for maybe 5 years from now. Now, please help me introduce Nadeem Abji. He's a fourth-year PhD candidate in the Electrical and Computer Engineering Department in the Communications Group. And he has come here today sharing his time in order to talk to us about consumer collaboration in power grids. And he has lots of interesting things to share with us. Please, let's welcome him.
Thanks for the introduction, Hagaf. First, let me say, wow, those are really good presentations. I know you guys didn't have a lot of time to work on it, but every group really touched on some of the key points. And I think you even covered a lot of what I'm going to talk about today, so I'm glad to see that. Also, I just want to say it's wonderful to see so many high school students here participating in the DEEP program. Hopefully at the end of this, you guys are as enthusiastic about engineering as myself and Hagaf and all the other instructors and lecturers are. So my talk today is actually entitled Consumer Collaboration in Smart Grids. And anytime during the talk, if something pops up in your head, you have a question, just feel free to stop me and ask. I want to make sure you guys are paying attention and following along. So if anything's confusing, you can just put up your hand or you can just scream out. Okay, so here is the overview for today's talk. Kind of what my objective is to work through a realistic kind of engineering problem with you guys and look at the kind of process that we go through. So first, the challenge is to identify a real-world problem. Okay, and then we go to some kind of theory, right? That's what we do in engineering. We apply different creative solutions, so we'll look at some theory. The next step is then to either do some research, see what other people have done in this area, and then contribute yourself to this field. And then finally, what's the last step is to talk about implementation. It's great to do all this research, but how can we actually make these things a reality? So breaking it down in terms of that, we'll start with talking about some of the smart grid design challenges. I know you guys covered almost all of these topics, and then we'll pick out one particular problem. Then we'll go over some of the theory, and the one we'll look at today is game theory. And then we'll look at some research that actually uses game theory for doing this consumer collaboration in smart grids, and then we'll quickly talk about some of the enabling technologies or how you would actually implement this. First, I thought I would talk a little bit about myself, so you know kind of my history, where I'm coming from, my experiences. I was raised here in Toronto. I went to high school here. I did my bachelor's here at U of T in applied science and engineering, electrical engineering. I had some work experience in the summers. I worked at Scotia Capital as a programmer, and then actually in my third year summer, I worked as an undergraduate researcher here at U of T, which was a really good opportunity. I got to work with a professor and see what we do in a university and how it's different from the industry. So I actually got to work on the research problem. And then that actually got me interested in research, and that's why I decided to stay here, and I did my master's, and now I'm working on my PhD. Some of the different projects I got to work on. How many of you remember when peer-to-peer started? I know you're pretty young. Yeah, what was it for? What did we use it first for? Yeah, sharing files, right? And why was peer-to-peer effective in that? Rather than just putting it up on a website.
It was too slow back then, and there wasn't a lot of storage.
Yeah, that's definitely any others? How do you think they used peer-to-peer? Remember Kazaa or Napster? I don't know if you guys might have been really young back then. Well, it had to do with legal problems, right? If you put up an illegal MP3 on a website, they can come and shut you down right away, right? But if it's in peer-to-peer, how do you stop thousands or millions of different people from sharing files? It's really hard to do. So from a legal standpoint, it was hard to stop that. But actually what we did here on one of our projects was peer-to-peer is actually really effective from a technical standpoint too. Like our student here just said, that you have more storage, you have more computing power. And so we looked at peer-to-peer and tried to apply it to voice over IP, video streaming, and all these other interesting kind of problems. In my master's, I worked in cognitive radio, which is in the wireless space, making more efficient use of the wireless spectrum and using software-controlled radios. And now kind of in my PhD, I moved more into this energy-efficient communications, but I'm looking at it in this smart grid context. So we'll start now with the smart grid design challenges. This is kind of an overview that I had. I think you touched on a lot of these topics. We talked about reliability. You want to be able to collect information and use it to operate the grid more effectively. We also want to be able to monitor outages and check the power quality, and because that has the potential to cause strain on the grid, right? So right now, does anyone know how they monitor outages? Any ideas? They wait for a phone call from somebody to complain that there's no power in their house, right? So that's not very, it's not the best way of going about it, right? So we want to be able to monitor the system and proactively manage it so that we can predict what's going to happen and know when there's an outage before having to wait for someone to call in. We also want to look at things like efficiency, so making more efficient use of the electricity system, less waste, and we want to be able to reduce our costs, both operational and maintenance. Okay, and then the last area is kind of the sustainability, which a lot of you guys mentioned. We want to accommodate local renewable generation. We want a cleaner electricity system so there's less carbon emissions. And we also want to have support for plug-in electric vehicles. Okay, so the one problem that I want to look at today, I think you touched on it earlier, maybe AGOP slides, is the peak to average problem. Okay, so you look at this chart, it's kind of it's not a real electricity demand chart, but kind of representative of what we have in the system. Okay, so this is electricity demand over time for, say, a small city or a neighborhood. So you kind of have this low amount, and then all of a sudden we have a peak during a certain part of the day. So why is this a problem? So first of all, we know that the utilities have to be able to supply the demand, right? The two have to match. So how they do this is that they have a generation mix. So they might use hydroelectric power, a little bit of wind, nuclear, to supply this, right? So when we get above this level, the problem is we now have to start going into these more expensive, dirtier sources. So we might use coal, right? And we know that's not the best way of going about it. So yeah, we need a system to be able to supply this peak level, and then we have to rely on expensive, dirty sources at this peak. So this is a big problem.
Can I ask something?
Yeah.
So you mean that wind cannot cannot help us to get our energy? So we actually need coal and nuclear to go to that peak?
Yeah, so the utilities, they have different sources that they use, right? So when we're down here, we don't need to use coal. We don't even have to use those plants. We'll just supply all the electricity we need from our hydroelectric, wind, and maybe some nuclear sources. Right? So you go in terms of what's cheapest and most efficient first, and then eventually to get here, we don't have enough hydroelectric, we don't have enough wind or nuclear. We have to use these coal sources. Yeah. So that's the essence of the problem. Okay. Any other questions?